Welcome to the world of robotic process systems. RPS is renowned for expertise in automating manufacturing operations, incorporating high levels of process control. Our success largely stems from the overwhelming acceptance of our standard solderability and lead tinning equipment. Our RPS 200 3-axis Cartesian robot is the industry standard for handling components in singular or mass volume through the process of hot solder coating of the leads. Our capability and willingness to work with customers has led us into customizing the RPS 200 for many other applications, such as forming, lead attach, welding, point-to-point flame soldering, brazing, marking, dispensing, conformal coating, cleaning, testing, and vision inspection. We have coupled our process knowledge with our experience in Cartesian knowledge and the most powerful software available to create the Opus One, the first workstation designed specifically for the systems integrator, fully ready to accept a variety of end effectors for specific applications. The Opus One is a 3-axis, closed-loop servo-driven system with a work area of 18 inches by 18 inches in the X and Y and 5 inches in the Z-axis, with travel speeds of up to 30 inches per second and repeatability to 1/1000th of an inch of true location. The robot controller is a 19-inch rack mount unit. The rear panel features a pre-wired terminal strip of all inputs and outputs, which are controlled through the software. For easy integration, the Opus One is pre-wired and pre-plumbed to the end effector head with 6 air lines and 6 signal wires. The software, also common to the RPS 200, features a selectable pop-up Windows-based system, enabling easy creation of a script. The main headers include program, with subheaders for selecting a program, editing, or deleting a program, and the ability to print or copy an existing program. Under the execute function, the system will run a pre-selected program and has the ability to step through the program line by line or go to the jog function. In jog, the bar graph and coordinate readouts correspond to the robot movement. The operator may use the teach function to move the end effector to a specific point and configure the point as a station. A prompt appears allowing the naming of that station, which will then appear in the picking list during the creation of the script. Under the configuration function, the user may install password protection or certain interlock capabilities, such as light curtains or door locks. The user may configure certain analog parameters for process operating windows. The stations taught in the teach mode may be reviewed and reconfigured for adjustment of their X and Y coordinates. To create a script, simply pull up the commands for setting the various speeds and accelerations in the 3 servo axes, then start to create the script by pulling down move commands or input and output functions. Once the basic script has been created, it is easy to utilize the repeat and subroutine functions, even nest subroutines in subroutines, to easily create multiple tedious movements. Using the various else commands, inquiries of the state of input and output devices can be used to determine process path. The dwell function operates to 1/100th of a second. At any time, the insert or delete command on the keyboard can be used to effect a line of command as the script evolves. RPS will provide the Opus as a complete turnkey process station. The configuration shown features a gas flame soldering system, enabling micro-soldering of components to a circuit board. This turnkey system utilizes the standard Opus fitted with 12-inch throat spacers to allow for the height of the edge conveyor. The edge conveyor allows the product to pass from station to station through the Opus, integrating it into a complete process line. The hydrogen gas is generated by disassociating demineralized water in the generator. Under continuous use, one filling of water will last a minimum of 5 days. The gas is plumbed to the flame tip. The temperature of the gas and the size of the flame may be adjusted over a wide range. The solder wire feeder is fully controlled by the software determining exact volume and feed rate. These precise controls allow for soldering even the smallest of components to the board in a very reproducible fashion without inducing any damage to the board or component. This process is especially useful when soldering through-hole odd-form components to a mixed technology board while maintaining an inline production flow. Hot iron, hot gas, hot bar soldering, and welding heads may also be integrated into the system. The Opus One and the soldering technology can be packaged to embed the Opus within the work frame and solder components from the bottom side as they pass overhead on the conveyor. To complement the soldering operations, the Opus One may be installed ahead of the soldering module to pick and place the odd-form components to the circuit board. The Opus will never become obsolete since it is designed to be easily reconfigured for completely new applications by RPS or your own staff. In our lab, we would be pleased to process samples and provide you with a video illustrating the flame soldering of your product. Flame soldering applications with high thermal masses are encountered, such as the case with multi-layer boards with large ground planes and massive components. The flame quickly brings the component and solder joint area to temperature, allowing rapid point-to-point soldering. This application could not easily be accomplished using other process techniques. The flexibility of the Opus allows for three-dimensional point-to-point soldering. Using our PID-controlled soldering iron tip, we were able to quickly develop a process for soldering large terminations to ceramic substrates. By exchanging the tip of the soldering iron and utilizing a smaller wire diameter, we were successful in soldering small terminations to flex circuits at a rate of 1 termination every 2 seconds. Pressed-in connector pins may be soldered point-to-point for high mix, low volume production, or soldered in mass using solder paste deposition and hot gas reflow. Hot gas reflow using multiple selective footprint nozzles to cover an entire panel with hundreds of solder joints, all made simultaneously. The advantage is high productivity with all joints made in approximately 10 seconds and an added advantage of controlled flux migration. This technique can be utilized to vaporize the flux and draw the fumes away from the components, leaving virtually no residue on the board or components. Nozzles can be designed for specific components to provide only the heat source necessary to reflow the paste without contacting or reflowing components near the solder joint area. This technique can be utilized to protect thermally sensitive components. RPS will utilize the Opus work cell when applicable, or design a special purpose custom system that may employ other operations, such as pick and place of odd form components to a board, bottom side soldering, electrical testing, marking, conformal coating, and offloading of finished assemblies with the highest levels of production and process controls embedded into the host controller. Robotic Process Systems will provide your solution for difficult point-to-point or selective soldering. Our customer list includes Allied Signal, AT&T, Boeing, Bourne, Harris, Intel, Litton, Lockheed, Motorola, National Semiconductor, Raychem, Samsung, Texas Instruments, and TRW. For more information, please contact our technical sales department at area 509-891-1680.